In this video, we're going to take a look at Bayes' theorem. So we're going to start with a few statements from previous sections. From those sections, we have that the probability of B given A is equal to the probability of A and B divided by the probability of A. But our general multiplication rule says that the probability of A and B is equal to the probability of A given B times the probability of B. So we can change the expression in the numerator and get that the probability of B given A is actually the probability of A given B times probability of B divided by the probability of A. And then we can actually further change this expression on the right using our marginal probability with the general multiplication rule. And that was that the probability of A is equal to, and this denominator down here, the probability of A given B1 times probability of B1 plus all the way up to probability of A given some B sub k times the probability of B sub k. Where B sub I is the ith event out of k mutually exclusive and collectively exhaustive events. So what does that all tell us? Well, that just tells us this formula right here, which is what we call Bayes' theorem. So this is Bayes' theorem. And make sure you go ahead and write that down. This is going to be used in our next example. Generally, examples that involve Bayes' theorem are going to, at least in this class, look like word problems that look pretty involved. But we're going to go ahead and take a look at that example on this next page. And through this example, we will see how to write out that theorem based on this example. But let's suppose a manufacturer considers marketing a new TV. In the past, 70% of new models were successful and 30% have been unsuccessful. Before releasing the model, the manufacturer does a survey to see if the TV has favorable or unfavorable reviews. In the past, 80% of successful TVs received favorable reviews, and 25% of unsuccessful TVs had favorable reviews. So if the review is favorable, what is the probability the television will be successful? All right. How do we actually interpret all of this? Well, let's first just write out the information that we were given and some variables related to that. So we were talking about successful and unsuccessful of whether the TV ended up being successful or unsuccessful, right? And we also talked about favorable and unfavorable reviews. And so we'll let F represent favorable reviews and F prime represent unfavorable reviews. And what was the information related to that? Well, what was the probability that a TV was successful? So that was given in the second sentence here. In the past, 70% of new models were successful and 30% have been unsuccessful. So the probability of S is 0.7, and the probability of S prime is 0.3. We were also told that in the past, 80% of successful TVs received favorable reviews. So that is, what is the probability of a favorable review given that it was successful, given the TV ended up being successful? Well, that was 80%, or in other words, 0.8. And we were also told that the probability that it received a favorable review given that it ended up being unsuccessful was 0.25, or in other words, 25%. Okay. Now, what does this question ask? This question says that given that the review is favorable, what is the probability that television will be successful? Well, what does that mean? That means we write P of S given F. So again, we were given that the review was favorable. We want to know the probability the TV will be successful. Let's go ahead and take a look at our formula again. So this is probability that the TV ends up being successful given it got favorable reviews. Well, this is equal to the probability of A given B sub I. So the probability of a favorable review given that it is successful times the probability of B sub I, so the probability that it was successful. And then we continue with this, filling out the denominator as well. So keep that in mind when we're filling out the rest of this formula. And what does that become? This becomes the probability of a favorable review given it is successful times the probability it will be successful, all divided by the probability of a favorable review given it was successful times the probability it was successful plus the probability of a favorable review given it was unsuccessful times the probability it was unsuccessful. And this is our situation filled out using Bayes' theorem. And then all we have to do is plug in the values here. So probability of a favorable review given it was successful is 0.8. And then probability that it is successful is 0.7. So this is times 0.7. All divided by, and then filling out the denominator here, we get 0.8 times 0.7 plus 0.25 times 0.3. We plug all of this in and do the calculation. We get 0.56 over 0.56 plus 0.075, which is 0.56 over 0.635, which is approximately 0.882. So about an 88.2% chance that our TV will be successful on the market given that it was given a favorable review in our survey. And so there's an example using Bayes' theorem.